All right, today we're going to look at parentheses and exponents. Just a reminder here as you're watching the video, if you need to pause it to make sure you're getting everything down, feel free to go ahead and do that. Also remember you can rewind to go back and look at something if you need to, if you don't understand it. So we'll get going here. First thing we're going to look at are negatives, and when we have parentheses and when we don't. Okay, so the first one here, the negative 10 to the fourth power, okay, that first one, if you think of order of operations, we do exponents first in order of operations. So the first thing we would do here is do 10 times 10 times 10 times 10. Okay, and then we would use the negative. So what I'm going to do here is put parentheses around that 10 times 10 times 10, and we're going to put the negative out here. So when we do that, when I multiply 10 by itself 4 times here, we're going to get 10,000. And then because of the negative, we get a negative 10,000 for an answer. Now if I go down to the next one here, the negative 10 to the fourth with the negative 10 in parentheses, that one, if we write it out the long way, we're going to have negative 10 in parentheses times negative 10 in parentheses, and so on. Okay, so now when we go ahead and we multiply that out, negative 10 times negative 10 is going to be a positive 100. A positive 100 times a negative 10 is going to be a negative 1,000. And a negative 1,000 times a negative 10 is going to end up being a positive 10,000. Okay, now if you kind of check your calculator on these two, I'll just bring mine up here. If I type these in my calculator just the way they look, so if I do negative 10 to the fourth, okay, you'll notice I get the negative 10,000. When I put the parentheses in there and do negative 10 in parentheses to the fourth, now you'll notice the calculator will tell you it's a positive 10,000. Okay? Now a 4 is an even power, so I just want to show you something here real quick. If I take that negative 10 without parentheses to the fifth power, so I'm going to do an odd power here, I get a negative. Okay? So whether without parentheses, whether it's an odd power or an even power, you're always going to get a negative answer. When I put parentheses on there, around the negative 10. Now if I take that to the fifth, you'll notice now when I do that, I get a negative 100,000 there. So this time I got a negative answer for that one. So if you remember back, we talked about this earlier, when they're in parentheses, if I take that negative number in the parentheses to an even power, like to the fourth, I'm going to get a positive answer. If I take a negative number to an odd power, I'm going to get a negative answer. So you can see if I did negative 10 in parentheses to the sixth, which is an even power again, I should get a positive answer, which I do. Okay? So just there's our difference between when we have parentheses around the negative number and when we don't. Okay, now moving on to the next one here. We have 2 to the fourth to the second. Okay? If I write that out, what that means here, so that would be 2 to the fourth times 2 to the fourth. Okay? So I'm taking 2 to the fourth times itself twice. Now if you remember the rule we talked about, when we multiply like bases, we add the exponents. So I would be taking 2 to the 4 plus 4, which is 2 to the 8th. Okay? Now, if you think about it, what else can you do with 4 and 2 to get 8? Okay, well, the shortcut here is I can do 2 to the 4 times 2. Okay, and this is your shortcut right here, 2 to the 4 times 2. Okay, so you see how it works with using how we did it when we multiplied like bases, it works out. So now the next one here, instead of taking that 2 to the second times 2 to the second times 2 to the second, I can just do 2 to the second times 3. I can just multiply the exponents. Okay, when I do that, 2 times 3 is 6. This ends up being 2 to the 6th power. Okay, so there's a rule there for that one. Okay, this is the power of a power rule. And the general rule here is a can be any number here. So a to the m to the n is the same as a to the m times n. Okay, that's our rule. Okay, again, pause if you need to make sure you get everything down. Okay, otherwise here we go to the next one. Okay, now we have it where inside the parentheses we're having two things multiplied. Okay, 2 to the 4th times 5 to the 2nd, and all that's to the 3rd. Well, because it's multiplication in there, what we can do is we can split this up into 2 to the 4th times 3 times 5 to the 2nd times 3. Okay? So 2 to the 4 times 3 is going to be 2 to the 12th. 5 to the 2nd to the 3rd is going to be 5 to the 6th. Okay, and that's what we can simplify that one to. So now if you wanted to do that with a little shortcut here, if you just remember, hey, it's multiplication, I'm just going to multiply those exponents. Okay, 4 times 3, again, there's your 2 to the 12th, 5 to the 2nd to the 3rd, there's our 5 to the 6th. Okay, so kind of the long way there and the short way. You can also do this with division. Okay, so if we took 2 to the 4th over 5 to the 2nd, and we took that to the 3rd power, what we would have if we do this the long way would be 2 to the 4th over 5 to the 2nd 3 times. Now what I'm doing here when I multiply fractions, remember we multiply across the top and we multiply across the bottom. So 2 to the 4th times 2 to the 4th times 2 to the 4th on top would be the same as 2 to the 4 plus 4 plus 4. And 5 to the 2nd on the bottom would be the same as 5 to the 2 plus 2 plus 2. We would add those up. So 4 plus 4 plus 4 is 12, and 2 plus 2 plus 2 is 6. Okay? So we add 2 to the 12th over 5 to the 6th. Okay? Now again, the shortcut way to do that, okay, down here is we would have 2 to the 4 times 3 over 5 to the 2 times 3. 4 times 3 is 12, so there's your 2 to the 12th. 2 times 3 is 6, so there's to the 5 to the 6. Okay, again, the shortcut way is much shorter. Okay, So we got a couple of rules here that you're going to want to jot down. Okay, so for these top ones, the rule is this. If we have, again, a can be any number. So in there, if we have a to the m times b to the n, that is the same as a to the m times p times b to the n times p. Okay? Down here, the rule is, for division, okay, if we have a to the m over b to the n to the p, that would be the same as a to the m times p over b to the n times p. Okay, again, take a moment and pause the video if you need to get these rules and things down. Otherwise, we are going to move on here. Okay, this next slide, really just kind of reviewing here that, again, when you multiply like bases, we add the exponents, okay? When we divide like bases, we subtract the exponents. Okay, so just a rule on that, and then just going over the parentheses there again. You can pause if you need to look that over. Okay, so here on the work time here, we're going to use our shortcuts here to get these done really quick. So 5 to the second to the 6th, all I need to do there is take and multiply the exponents. So 2 times 6 is 12. This just simplifies to 5 to the 12th. Okay, looking at letter B, well, this is going to be the 2, it's 2 times m to the 3rd. Okay, so I can take 2 to the 5th, and then I also have the m to the 3rd to the 5th, so I'm going to take the 3 times 5. So that ends up being 2 to the 5th times m to the 15th. And actually, I don't even need to put the multiplication dot in there. I can just write them next to one another like that. Okay. Now for letter C, we got 7 to the 4th over 9 to the 2nd, all to the 3rd power. So I can just take 7 to the 4th to the 3rd, which would be, I multiply the 4 and the 3 and get 12. 9 to the 2nd to the 3rd, I would just multiply the 2 and the 3 and get 6. So we'd have 7 to the 12th over 9 to the 6th. Okay, and then the last one there, letter D, we've got negative 10 to the 3rd to the 8th. That is going to be the same as negative 10 to the 3 times 8. 3 times 8 is 24. Okay, again, if you need to pause to get any of those, or look back at the rules to understand what we did to get those, please go ahead and do that. Okay, these next ones, we're using the same idea here. So this is like w to the 1st here. So if I think of all these have 1s for exponents, okay, 1 times 5 is 5, so that's w to the 5th. X to the 1st to the 5th is going to be x to the 5th. Y to the 1st to the 5th is going to be y to the 5th. And then I have the z to the 2nd to the 5th, so I need to multiply the 2 and the 5 to get z to the 10th. Okay, for letter B, okay, now does the 4 outside the parentheses only goes to that second set. So the first one, I'm going to have c to the 2nd, d to the 5th. In the second one, the c to the 3rd to the 4th, when I multiply the 3 and the 4, I'm going to get 12. And then again, d is d to the 1st times the 4th. That's going to be d to the 4th. Now I can combine the ones that have like bases. So c to the second times c to the 12th, now I have to add the exponents, I get c to the 14th. d to the 5th times d to the 4th, again, add the exponents, that gives us d to the 9th. So that's our final answer for that one. Okay, letter C. Up top here, we're going to simplify the top first and then simplify the bottom. Okay? Because that exponent of 2 on top, that only goes to the stuff on top. The exponent of 5 on the bottom only goes to the stuff on the bottom. So we are going to have 8 to the second. W to the 5th to the second is going to be W to the 10th. And Y to the 6th to the second is going to be Y to the 12th. Okay? All of that is going to be over. Again, this is W to the 1st. So when it's not there, so 1 times 5 is 5. So W to the 5th. And then Y to the 2nd to the 5th is going to be Y to the 10th. Now I can simplify by dividing. So again, when you divide like bases, you subtract the exponents. So the 8, there's no other 8 on the bottom, so I'm keeping the 8 to the 2nd. But my W's, I've got W to the 10th on top, W to the 5th on the bottom, so I need to subtract. I need to do 10 minus 5 there and get W to the 5th on top. And then I've got Y to the 12th over Y to the 10th. 12 minus 10 is 2, so that's going to be Y to the 2nd. So this all simplifies to that. Okay? Now with letter D, because that 2, the exponent 2 on the outside of the parentheses, that goes to the whole fraction. So I'm actually going to simplify inside the parentheses first. So from top to bottom. So again, the 8, there's no other number, so I know that 8 is going to be on top. I've got W to the 5th over W to the 1st. Okay? 5 minus 1 is 4, so that's W to the 4th. And again, that would stay on top. Y to the 6th over Y to the 2nd, I'm going to subtract those. 6 minus 2 is 4. So we've got that on top as well. So I'll end my parentheses, I've got the 2 outside here. So now what happens is, it's 8 to the 2nd power, which is just 8 to the 2nd. Okay, and then we have the W to the 4th to the 2nd, which is going to be W to the 8th. 4 times 2 is 8. And Y to the 4th to the 2nd is also Y to the 8th. So we end up with 8 to the 2nd times W to the 8th times Y to the 8th. Okay, again, pause if you need to. This slide here is just some of those general rules of exponents that we have talked about. So you'll see it starts with when we multiply like bases, we add the exponents. Okay, then we did the division one. When we divide like bases, we subtract the exponents. Anything to the power of 0 equals 1. And then here's the 3 new ones that we did today on the bottom. So again, if you need to, take a look at those. Last slide here, just to close this up. When should you apply exponents over parentheses? Give an example. So we should apply exponents over parentheses when inside the parentheses it's multiplication or division. Okay, then it works. But you should not do it when it's addition or subtraction inside the parentheses. Okay, it's not going to work out then. So that concludes this lesson here. Make sure if you need to go back and copy anything down, that you do that. Otherwise, good luck on your homework. Hope this helps.